Hi, everyone. We're going to get started. Welcome to the San Francisco Big Analytics Meetup. I would like to introduce to you our speaker for today, who is, I'm going to pronounce this right, Stepan Pushkarev, and he is the CTO and co-founder of Hydrosphere. And today he's going to be talking about DevOps. So a lot of us are familiar with creating algorithms, but he's going to talk about everything else that needs to be done in order to use these models in production. He's going to be talking about testing and building and so on and so forth. So everyone give him a round of applause.
Yeah. Thank you so much for introduction, and thank you organizers for making this happen, for the opportunity to talk here, and thanks Yelp for providing this wonderful place to meet. Before we start, is it the first meetup this year?
It is.
Oh, that's great, and I'm glad this is on top of your New Year resolutions to visit this meetup and invest your time in learning new things and discussing this topic. Just a few words about myself. I spent 13 or 14 years in software industry on different roles and different positions. Mostly worked as a contractor and consultant. And I've founded 2 product startups so far. And one of them is Hydrosphere.io. And basically all the talk ideas and demos are based on the stuff we are building there. It is all open source, and I encourage you to check it out after this talk. I have almost 60 slides and 4 short demos, so I'll be moving very quickly. Do not hesitate to interrupt me and ask any questions as we go along. I would like to make this talk very dynamic and interactive. Yeah, some stuff is fun, some stuff is crazy, so please be prepared to disagree with me as I speak. The talk title is DevOps for Data Science. For me, actually, DevOps is just a catchy buzzword to optimize things. Our world is suddenly not optimal at all. So, and obviously, data science and the big data analytics space as a newly just emerged field has a lot of gaps and a lot of not optimized things. And as a keynote, I would like to use this slide. I wish I would be an author of this slide, but I've copied it from Josh Wells, who is famous in making tweets and such highlighting very important problems in a very informative way. Obviously DevOps is not just about dev and ops. There are a lot of people involved into product development, data engineers, data scientists, QA people, web engineers, business and ops. In this talk, we'll be trying to resolve this loop of sadness. Let's warm up a little bit, and could you raise your hand, left hand, if you are married? Wonderful. Could you raise your right hand if you are a data scientist? Could you raise both hands if you are a data scientist and you are married? And you are still alive, and you are still happy. That's perfect. So seriously, this talk is for people who are aware of other 99% of data science. Meaning that you work with this every day, you struggle with all these issues day to day, and you know everything beyond the basic tutorials. Just to make everybody on the same page, this talk is not about infrastructure. This is an interesting topic, but it's not a focus of this talk. We're not going to configure classical DevOps tools like Jenkins and monitoring tools. I think it's like a done thing. You could go and learn it in a web and just set up yourself. And it's not I'm not going to tell you what Agile and DevOps is. I hope you are all using it every day and you've learned it. Basically, there are 3 parts of this talk. I want to make everybody on the same page and highlight the problem statement we're trying to deal with. And there are two practical parts, and we will be deploying analytics as a service, and then we will monitor it and test it and do some interesting stuff like analytics for analytics. Just a question to you guys. So why do companies hire data scientists? What's your thought? What's your opinion? Find patterns. Great. What else? Okay, okay. Raise evaluation. Okay. What else? Make better decisions. Wonderful. What else? Okay, let's formulate it this way. I would say to make products smarter. Did you ask yourself, well, what is the main product of the company you work for, and how do you make it smarter? Let's remember this slide and move forward. And what is a deliverable for data scientist and data engineer? What do you physically deliver day to day into production? Insights, okay. Models, anything from this list? R Python script, Jupyter Notebook, and just a question, is it aligned with making products smarter? Okay, I think it. Yeah, it's of course it's important things. It's something useful, but there is a big gap between the code written, the Jupyter Notebook or BI dashboard, and the final product, which is smart enough to support business decisions. I would state it in this way that a deliverable for data scientists should be data pipelines and machine learning models deployed as pluggable, testable, supportable, and maintainable analytics services. What does it mean, services? Very, very wide term. This is something which is running 24/7, and it has nice and bounded context. You could touch it physically, you could touch it through the API or through other methods. I think that this slide is not for the current talk, but yeah, still there are some companies which are trying to re-implement academic papers and put it into production. This is the second option. I guess this is a tragedy of any company I know, that we're still struggle and we're still debating who will write the code. And could you just step back and think how far we are from delivering smart products? Because writing code should be the most simple and the most trivial task in the product development. So this is just highlighting how early we are in a stage of delivering the products. Option 3 is just do not rewrite and run it in cron. It's, in my opinion, it's better. I think everything is better rather than rewriting things, because it creates a sense of ownership for data scientists. Even if you wrote a bad code, let it be deployed as it is, and it will fail, and we will learn from this failure. And the next iteration, we will make it better. So, but it is 2017, and we are still building systems using cron schedulers. We are running our notebooks one by one or in a workflow manager. And when I see the headlines and landing pages from really thought leaders and from the companies, from unicorns, they put the analytics from development to production, using cron scheduler and notebooks, I think it's like trying to mimic a real person using a marionette, and this is, in my opinion, not the way to go. What is the best option, I think, is to build a software to eat data science. What does it mean? So every company should become a software company, and every data science problem should become a software engineering problem. Why? Because it should be running in production. This is one point. The second point is, remember how DevOps was born. Engineers came into sysadmin world and refactored all that shit, all that bash scripts, and made wonderful products like Ansible, Docker, Kubernetes, and others. And I think now it's time to get this to do the same with the data science process. Let's go into details a little bit. So there is a great talk by Daniel Tarkelang. He's talking where you should put your data scientist. And the resume, I recommend you to check it out. And resume is that you should move from isolated marginaling mode into integrated mode. I still know the companies where CEO is a professor and data scientists are first-class citizens, and they do everything. They start building web applications because they know Python and they could do something in Django. They start deploying analytics into production because they know how to use cron, and this is a nightmare. You should build cross-functional teams which are focused on end-to-end products rather than isolated pieces of software. This is out of the scope of this talk, but we should mention it that environments and infrastructure matters. There is no ready-to-go solution right now for big data analytics for fully managed Apache Spark environment with fully isolated and elastic resource management. It's definitely an interesting topic, and if we own the operations we build as a team, we usually build a cluster on EC2 and EC2 ECS, if you know what it is, and Spot instances with some secret sauce for making it really auto-scalable and really elastic. So, the third recommendation is really let data scientists to write less code. It's not his blame he has to write 3,000 lines of code to do simple things. And this is a problem of software engineer who didn't provide a right framework, the right abstraction for data scientists, and he has to deal with parsing CSV file and other stuff. This is nothing new. This is happening all the day where tools become more and more mature, and life of data scientists and our lives become easier. The third recommendation is to deploy analytics as a service, and I will move forward very quickly, and because we will discuss it in details in the next topics. And of course, to make this loop closed, you should you should do collecting, building the model, and deploying it and monitoring continuously. Day-to-day requirements are changing, data is changing, so it's not a one-way process. So here we are. Do you follow me so far? Or okay, sounds good. So everybody on the same page. Let's take a look what it is. Let's summarize why we need to deploy analytics as a service. It nicely defines a deliverable for data scientists. It's physically could be plugged into end-to-end product and could be used in cross-functional teams. And with the right tooling, it will allow a data scientist to do it himself. Let's take a look around. What do I mean by deploying by services, analytic services? Some proprietary services like Alchemy API, Google Prediction API, and can we make the same? Can we make our own service on top of Apache Spark? Let's try. Before we move forward, let's take a look around one more time and for bad practices. This is just a webinar I occasionally joined a few weeks ago, and guys were talking about moving Spark applications into production. Yeah, and they were talking about the implementing a business logic in Apache Spark, extracting data and sending some emails, notifications from Apache Spark. This is not the way to go. This team is marginaling from the big data engineering perspective. So big data engineers are trying to do everything in the context they know. And yeah, this is this is an example of the architecture I literally see in every company. So this is a clunky mechanism I've just described before. We know cron, how to use cron. We know how to use MySQL. We know how to use SQL. Let's build an API. Instead of doing a really simple API call, we really reinvent the wheel with certain flags and like unmanageable states in database. This is an example from Microsoft Azure. If I will hand off this API to a web developer, he will kill me, I guess, and because it doesn't make sense for him what column names and all these arrays are, because it's just a one-to-one mapping to your database or to your model output, and yeah, it's too low level. Yeah, and here is a solution. We've built a service for exposing jobs and analytics jobs and machine learning services as machine learning models as web services. Basically, there are three types of analytics services you might need. It is enterprise analytics services, reactive or streaming services, and real-time machine learning services. Let's start with the first one. Basically, these are services which have heavy Apache Spark jobs on a background, and they couldn't be pre-calculated in advance, and your application just executes parameterized jobs and get result back. Various examples from reporting, simulation, forecasting, or just some ad hoc tools for business users. We're very simple. Let's do a demo, the first demo. Here is a canonical example from Apache Spark. A text search example. How to mystify it. Our service has a name, Mist. How to make a service from this Apache Spark program. Basically, you will like to, it makes sense to expose these parameters, which are hard-coded, to the end user. So you could specify what a filter you would like to process and get result back. So we will take this Apache Spark program and add few lines of code. Let me enter presentation mode here. This is just original Spark program a little bit cleaned up, and it's wrapped with some API, with some DSL, and it basically does what it should do. And you just make a Spark, execute a Spark program, and return a result. And this is magically allows you as a data scientist or a data engineer to deploy it as a service. So you will have it. This is a UI, just internal UI for debugging stuff, and this is a service we've just built, and you could just run it and get instant result back. So it executes Spark program on the background and return a result. Very simple, very straightforward, but surprisingly, it is missing right now in the open source tools, in the open source ecosystem. Let's turn back to the presentation. Another type of services, you imagine that your log search application, and you could deploy it into a streaming context and receive notifications or alerts, insights as data arrives. So from the application, you start the job, you receive results, and you should be able to modify this streaming job on the fly, meaning that, okay, I've deployed a certain filter, let me modify it on the fly and receive a different alert. Or probably I would like to use another noise filter, another model to be deployed in a streaming context. This is not the only one use case. Streaming use cases seems to be very advanced from the first view, but let's take a look at the most low-hanging fruit for Apache Spark and Hadoop installations. It's reporting. Yeah, obviously, they were replacing data warehouse solutions by just changing a software behind that. So classical architecture of reporting services have a Hadoop or Spark job running by cron, nightly job, and which saves result into data warehouse. What I'm proposing is not to save the results into data warehouse. It might be saved into for caching purposes or logging purposes, but it's not a responsibility for analytics engine and processing engine to save results for the end users, because it's just not its responsibility. Let's decouple it using a messaging API. Let's decouple it using Kafka or Kinesis or any stream processing, and allow reporting application to save it wherever it wants. It might save it index it in Elasticsearch or NoSQL database. It doesn't matter for Spark because it's calculated a report and pushed it to the upstream application. And it allows very interesting architectures like what if you would need to subscribe to this topic by other application, audit application, notification application. So it is real nicely decoupled from the analytics stack. And analytics on its own, the data scientist and big data engineer, they don't care about that. They don't care about life cycle of this report, about how to, and so on. Just one more demo, how to, we take this job and deploy it in a streaming context. Basically, it is the same code base, just deployed in a streaming context, and we use API to publish result to the upstream application. And here how it looks like. So let's run streaming job. So it's an Infinity job started. Just a few words. This is all this stuff is available using HTTP or messaging API. This is just an internal tool to like a UI application for the Mist. Let's see. Started. Streaming job started, and we have MQTT client connected. Right, yeah, and it is publishing results of its. And yeah, and web developer could build any application in 30 minutes on top of that. Okay, we were talking about batch context and large-scale context. What if we would like to train our model in a distributed fashion and deploy this model for a single row scoring into real-time environment with a high throughput and low latency? This is a pretty different use case, but it is the same code. It should be the same code base. There is no difference between offline applications, online applications, machine learning applications, not machine learning applications. Actually, everything is blended right now. If you will take a look at the Facebook homepage, there is no difference between machine learning and not machine learning. So you could put it in a low latency context, in a online production, or in a real-time streaming processing, like Apache Flink or Kinet. Just a few words about PMML. You might be aware of that. Just please don't get me wrong. I don't have anything against PMML, but in my opinion, it simply doesn't work, because all the machine learning libraries use its own format to serialize its models, and in fact, it's not an issue. And it's not an issue if you have a serving layer and you could read this model saved into Parquet, JSON, XML, or any other format. And what is deliverable for a machine learning model? It is integration with a large-scale training engine, with a single-row scoring engine, and with monitoring and testing. If we define a deliverable for a machine learning model, so it's not a matrix, it's not a function. This is something which is I've just described. Then it will make our life easier. And if we zoom out, we could even build a repository of different models with different engines, and if we package it properly. We could package it in a binary file or in a jar file or in a Docker containers. It doesn't matter here. This is just a vision. Let's go back down to the earth. We have a vision, but we have a Spark, and let's just demo how we can train machine learning model in Apache Spark in a distributed fashion, and automatically have it available for real-time scoring or serving. So we will take another canonical example from Apache Spark documentation. This is a text search pipeline, text document pipeline. It has. Does anybody aware of new changes in Apache Spark 2.0? Is there Apache Spark users in the auditory? Okay, sounds good. At least you will learn it. Okay. So there is a feature in Apache Spark. You train the model, and you could save it to a Parquet file for later use. Obviously, if you would like to use it in a real-time environment, it doesn't make sense to use Apache Spark context and scheduler, because it's a large-scale processing engine. It's not designed to be a single row scoring engine. And what you can do with Mist is to just implement a simple serve method. It uses abstractions and DSL from Apache Spark. The only one difference is it will use a local data structure instead of distributed data frames, and it will allow you to score models in real time. So basically, it is training and serving. And to demo this, I'm going to fire a classification. So I've exposed this text parameter to the user interface, and I could serve it, so it's instantly served. To make it, let's measure the latency here. Oh, yeah. Let's measure latency here. So this is 50 milliseconds. My laptop, so it's pretty much like any Unix command. So it's pretty instant. This is the way to go. And moving forward, so we've deployed our analytics as a service. We have real users. We have it online 24/7. And now what we need is to continuously update it, continuously test it. And yeah, we already have a regression because we have new changes come in production. We have state, because data operations are very stateful. You couldn't implement just the unit tests and do everything like web engineers or classical Java engineers are doing. And data drifts. Your model lifetime is very limited. So if it works today, there is no guarantee it will work tomorrow. And so you should implement a continuous monitoring for the models to ensure that they work as designed. From the TDD world, somebody might say, okay, just write tests. Actually, it's not so easy, because there are new kind of tests, new kind of validations in a data science and data engineering world. and integration tests are often impossible. So how to do that? How to do that? We need. Does anybody know data QA people? Do they exist in the world? I don't. Actually, they haven't born yet, I guess. That's why we're in trouble. We could even blindly trust, what we have just deployed. So yeah, well, let's brainstorm on some crazy idea. What if we will add AI here? Oh yeah, formula for the next 10,000 startups. Let's approach it this way. There is a thought that data structures should be smart, must be smart, and developers should be. Yeah, that's true. That's true. If you will think that, example, data frame from Apache Spark, it is much smarter than its users in terms of distributed computing, and it happens all the time. And what if we develop a DSL and data structure which is smart enough to learn from data patterns and trends and detect anomalies and be self-QA? Sounds crazy, but let's think a little bit. If we narrow down this use case, for example, to data validation, so the task is to validate data coming into the pipeline. We will start with some regular expressions, and eventually we will build some classifier to filter that incoming data. And what if we scale it out and make it and generalize and apply to any data set we have? Let's move forward from a different perspective. What is our big data infrastructure and big data landscape from the QA perspective? If I'm a QA, it's not a black box for me, it's a black sky for me with all the stars there. And how do people check that universe is not broken today? They observe and they monitor it and they find patterns, they measure frequency of some events, and surprisingly that works. We know a lot about our universe by this time. And yeah, monitoring, we have some ops guys and maybe engineers would say, okay, we already have Grafana, Kibana, yeah, and a little bit marijuana to make sense out of it. No, we don't need that. We don't need that for data science. It is designed for NOC, Network Operation Centers. It is very straightforward. It is unuseful for our purposes. Let's think a little bit further. So metrics, monitoring, correlation, insights, isn't it a big data analytics task on its own? And you are a data scientist. Can you get insights from all that data, from all that metrics and signals you receive from your system? And yeah, and here is a solution. So we can emit metrics from our big data universe, feed it back into our Apache Spark context, and analyze there. So basically, we built a quality model of our system. Model meaning machine learning model. And we could use this model to make our data structures smart enough. So this is a vision, this is a high-level idea. And what are the benefits? The most important, you don't need to talk to ops. You don't need to go and buy Splunk or install Grafana, Kibana, and all that stuff. You're already in a context. You're already in your favorite ecosystem of Apache Spark and Apache Kafka. And if we put data scientists in a loop, for example, if we have a certain metric coming from our system, we could ask a data scientist, is it okay to have data triple during this metric triple during last day? If it's not, if it's okay or not okay, we can learn from that. And yeah, and the beauty of this architecture is unlimited flexibility. So basically, you could implement any model in your Apache Spark, or you could use existing algorithms or simple thresholds and other stuff. It was a vision, and we are in the process of defining and shaping the product, which is Hydrosphere Swirl, a system that creates a swirl of analytics for analytics. So the high-level architecture is pretty much similar that I have just showed. We have original machine learning pipeline, we emit metrics, we feed it back using Kafka into the same context, and we run a set of streaming and batch jobs to analyze that. Yeah, I hope I'm not running out of time. We have time for the last demo. What I'll be demoing right now. Imagine you are ad tech company and you are showing ads to happy users. You parse it Twitter users. We parse the tweets and we have a pipeline, machine learning pipeline, and we emit a certain metrics from different points of our system, and we learning from that metrics and monitor quality of our pipeline. So basically, what could happen? Data pipeline could be broken, and your metrics will be red, or a new machine learning model could be deployed with a certain bug in that, and a particular metric would say to you, would notify you about that. So this is a story, and this is a demo. This is a pipeline we have. I've just described to you. This is a Twitter ingestion rate. We are ingesting. This is a leaf right now. This is, we could create kind of dependencies between analytics jobs, and let's deploy something buggy. Here we go. So this is another model. I have bad data set naive model, and I would like to start this job just to break something. Working. It will take some time to warm it up. Jobs, good. Yeah, let's wait. It will be broken. Yeah, just a few words while it's running. These are not just the metrics from a time series database you might usually have in a monitoring tool. These are all insights from particular analytics jobs. So there are Apache Spark jobs behind every metric, and they expose their insights to this UI. Oh, yeah, it's broken. Why? The model broken, and we could inspect it, and fix it. So basically, if we would stop the whole ingesting stuff, it will react as well. Yeah, I have just stopped ingesting job. I'm trying to break it, and I'm trying to get notified about it. Okay, it's healthy. Second, guess it's still alive. Oops. Okay. Leave there. Some delay. MQTT layer. Yeah, it looks broken. Yeah, so right now it's entirely broken. And yeah, this is simple mechanics. We are experimenting with the usability, and this is just we're doing some prototypes to evaluate this high level vision. Of course, it should be integrated into day-to-day process of data scientists, and it could be easily integrated into hosted notebook environment where you already design, you already crunch data, you visualize it already, and you could just add metrics from your working environment there, and you could just configure a quality monitoring pipeline or quality monitoring engine from that view. So, any questions so far? Yeah. Yeah, some. Yeah. Actually, it depends on your actual pipeline, and of course, it shouldn't be your system. It shouldn't be parameters of your machine learning model. It doesn't make sense to monitor it. It should be something inputs and outputs, and probably a business metric. So you could drill it down from the top level to the details. Yeah. So it's as I mentioned, it's a quality model of our system. Actually, it depends on your organization structure. So if you would like to involve data scientists in this process, so I'm own the product till the end, to the production. Right now, data scientists just drop products when they done an algorithm. They've built a machine learning model, and that's it. That's not their problem how it is running in production. What I would do, I would put data scientist in a loop in that. So he will be notified or he will be alerted. Of course, if your organization is quite big, we could easily get integrated with any NOC operation centers and whatever. So just a few words about the state where we have a vision I've just described, and we're trying to productize this. So the first part for deploying analytics models and analytics jobs as a services is like it's productized. It's easy, and it's done. You could use it. The second part is monitoring. Is where build. This is, you see, it's not a product. It's a prototype, and integration with different tools, I guess, is maybe iteration. The next iteration, or maybe 2 or 3 iterations. Sure. That's why when we will build the core, you could deploy it yourself, and the rest of the integrations and enterprise stuff, it's probably a matter of other companies who will support this tool. So if our tool will be useful, they will get integrated themselves. Yeah. This is interesting. Okay. Good question. The question was regarding reporting architecture. That the most common architecture right now is to query data warehouse directly using SQL on Hadoop solutions or something like that. Yeah, it might work. But who is a user of your BI tool? How many users you have? 3 or 4? It's probably business analyst, data analyst, and this report is shared to some stakeholders. 3, 5 users. Is it worth to make all that big data stuff to make happy to users? So and I believe that the real value in building end user application, if that report not shared, would be run by your customers, this is the value, and your customers wouldn't call SQL on Hadoop because. Yeah, it's just a different purpose. It is for internal. If you have internal analytics tool or BI tool, yes, it makes sense to build that report and share. But if you have an enterprise architecture, if you have different components, different systems, yeah, you will certainly end up building some service which is responsible for reporting. Any other questions? Okay. Yeah. Thank you so much. And we are in a very interesting stage. Well, of course, we are looking for a feedback for advisors, mentors, partners. Of course, we're happy to have some pilots and yeah, stay in touch in GitHub and LinkedIn. Thank you.
Okay, just to confirm, there are no other questions? Any other questions? Okay, then that's it. Again, thank you very much. And I'd also like to thank Yelp for hosting. And that's it. We'll see you at the next event.
Thank you.